Okay, this next example is going to take the next step in developing graphs of motion, and that is from a verbal description of the motion. Oftentimes, this is the most difficult skill that students have to apply in this unit in terms of the graphs. Being able to take a description and plot out the motion of the object. So if you look at the situation, obviously it's the summertime. We come up with these ideas. The nagging mosquitoes that buzz around our heads and try to take us down and suck some of our blood. In this case, I'm sitting down and I notice a nagging mosquito that buzzes towards me from the left, from my left, and slows down to a stop right in front of me. Then I lift my hand to take a swat at it, to knock it out of the air, and when he sees me, he picks up his speed to the right and then cruises away at a constant velocity. So as you can tell the way that this is written, me, myself, where I am, my location, is our origin. So I'm going to call me the zero position. So if the mosquito is buzzing towards me from the left, it's got to be starting somewhere in the negative position area of the graph. And by the time it reaches me, it's made its way back towards the origin, back towards zero. So let's see what's going on. It's slowing down to a stop in front of me. So by the time it gets to me, it's not moving, it stops. So that means its graph must be flat at that point. Well, if it's coming towards me and it's slowing down, that means it must have had a steeper velocity, a larger velocity that's going down to a smaller velocity. So it's got to start with a steeper slope, and by the time it gets to me, it will have flattened out. So you're going to have a curve looking like this. Okay, so then it stops in front of me. So for a certain period of time, it's not moving and at the origin. And then when I lift up my hand, it speeds away to the right and then cruises at a constant velocity. So for it to speed up, the slope has to go from flat to increasing. So during the next interval, my mosquito is speeding up and to the right. So now I'm in the positive direction relative to me. I'm the reference point, right? The origin. And then it moves away at a constant velocity. So from this point forward, a straight line, no curve. Okay, so I've got 4 segments to this motion. We've got the position time graph. Now let's look at the velocity time graph. So I start with a positive velocity because I'm moving back towards the origin but slowing down. So I start positive, and by the time I reach in front of me, I have come to a stop. So my velocity is 0. Then from here to here, not moving. So my velocity is 0. Then from here to here, speeding up to the right, so I'm getting a steeper positive slope, so I'm doing this. And then from this point forward, moving at a constant velocity, so V is flat. Okay, so there's an example of taking a description of the motion and using it to develop the position time graph and the velocity time graph. In the next video, I'll give you a couple examples of these to work on.